the part 2 of the lecture number 3, example 3.1. If you have the catchment, and the area of the catchment is 25,900 square kilometer, receive the annual rainfall with the 510 millimeter. So assume we can draw the shape of the catchment area. And this area, this the catchment receive the is rainfall. You see that this say that annual rainfall. You may expect that in this case the delta T should be 1 year. Okay, and runoff stream runoff from the catchment is Q. Q is 170 meter per second. So now its time step is different from second to 1 year. The estimate annual operation. So the question we want to find what is the operation in terms of the millimeter per year. Okay, because it is annual operation for transpiration from the catchment. Okay, based on this the given information, we can start to write the photovoltaic equation. For example, inflow rate subtract outflow rate equal to the chain of flow rate respect to time divided by time. In this case, inflow is mean the rainfall, and about the outflow. So in this case, we have the evaporation from the catchment. So outflow is E plus the Q equal to the chain of storage divided by delta T. In this case, we have just one equation, so we have to assume that the chain of storage is equal to 0. Okay, so we can rearrange above equation to rearrange again. We want to get operation E time equal to okay. So E time delta T means evaporation rate time delta T. So we got the volume of the total volume of the evaporation, and now we can substitute, given the evaporation is already in terms of the year, so we can write rainfall is 510 millimeter per year. Okay. The next we have to convert the flow from second to year. So given 170 cubic meter per second, so you have to multiply to 1 year. We have 365 days, 24 hours, and 24 minutes, and 24 seconds. So it means it's second per year is unit, and divided by the area 25,900, convert to square meter. Okay, so on the top is cubic meter divided by square meter, and we have to multiply by 1,000 to convert from millimeter to meter. Okay, so final we have like E equal to 5,010 subtracts 207 millimeter. So the solution should equal to 303 millimeter. Okay, that is the answer for the first problem. For the second problem, the volume of the sun surface runoff from 10 kilometer square catchment is 1,000 million liters. What is the depth of the runoff in millimeter? Okay. So in this case, we can write a Q. The unit of Q is 10 million, 1,000 million. It's a lit. Okay, so we can divide it by area to get in terms of the depth. In this one, we convert from lit to cubic meter first. Okay, 1,000 lit per cubic meter, and divided by the area, 10 kilometer, 10 times 10 power 6, convert to meter, and convert cubic meter divided by square meter, and convert to millimeter. Okay, so we got like Q equal to 100 millimeter. Okay, for this case in Australia they present the unit of Q in terms of million cubic meter, because they can divide it by from 10 million and 1,000 million. You can be divided by square kilometer. You can get like, okay, easily to convert from volume to the depth by just the number of the volume in unit of million liters divided by the area in unit of the square kilometer. We got the depth in terms of the depth. Okay, this problem example 3.1. Elevation of storage water in the farm pond in 103.2 meter at the beginning of the month of a month. Okay, so we have like the farm pond. So in this case, they talk about the at the beginning of the month. Okay, that is the level of the in the pond, and inflow water is 6 cubic meter per second. So we expect that the inflow okay, and the outflow is 6.5 cubic meter per second. And pond receives the 145 millimeter of rainfall. And stormwater loss from the operation is 6.1 centimeter. So this evaporation So in this case, we expect that we can the delta t or not what is the area of the surface area of the pond. The area of the pond is 50 square kilometer. They want to know what is the calculate water surface elevation at the end of this month. So the time scale is from the beginning of the month and the end of the month. So we expect that this problem they want the time step for calculation is just 1 month. Okay. And they want to know what is the water elevation of the pond. It can be like this. Okay, so that is what is the water elevation of the pond. It can be less than or greater than 103.2. It depends on the inflow and outflow. Okay, so we can start from writing the equation, water bound equation. Inflow rate subtract outflow rate is equal to the change of storage respect to time. Okay, so what about the inflow? This is the rainfall, inflow, and plus the Q in to the pond. For the Q out is mean outflow, it means Q out plus evaporation, snow infiltration is equal to delta S divided by delta T. So we can rearrange this equation to get the delta S that we want, that unknown that we want to know. And delta P Okay, next we can substitute the number in here for P given the 555 millimeter is millimeter per month, so when we substitute the density is month, so month will be cancelled, so we got the 545 millimeter plus we can subtract Q in and Q out, and we have to convert Q from unit of cubic meter per second to cubic meter per month, so we have to multiply by, and assume that 1 month have a 30 day, 24 hour, 60 minutes, 60 seconds, so we have second per month and have to multiply by 1000 to convert to millimeter. And the last one is the evaporation, so we have to evaporation is means we have to (6.1) centimeter, so we can convert to millimeter. Okay, so we have no space, so it means we can write down here delta S is equal to 145 subtract 25.29 and subtract 61, so it means our part is in the same unit of the millimeter, so we can subtract that. The change of the storage is equal to 58.08 millimeter. So we can say that elevation of water surface equal to 103. Convert to meter, so we got increase the water depth into 103.258 meter. Okay, that is our solution. In this case, we convert everything in terms of the depth in terms of millimeter. You can do it another way. You can convert every term in terms of the volume or cubic meter, and we can do the same way to find the solution. Okay, the last problem. The catchment area of the small catchment 1.5 square kilometer. Controlled. Receive the rainfall 10.5 centimeter in 60 minutes. So this means is 1.10 centimeter per 60 minutes. Okay. So this means the TR, duration of rainfall, is 90. And Q, there is no outflow at the beginning of the storm. After storm, average outflow is 2 meter per second. It takes about 10 hours to flow out. Okay, the question, they want to know loss of water from the infiltration, evaporation, and transpiration. So it means what is the loss? Okay. And the second part is one. Runoff coefficient. Okay. So we can start the same way, start from the basic water balance equation. Inflow subtract outflow is equal to the chain of storage. In this case, the inflow is a rainfall, outflow is the Q, runoff, plus the evaporation plus the infiltration. Okay, next we consider this part is the loss that we just want to find, and we have only one equation, and we assume that we have to assume, because we have one equation, one unknown. We assume the chain of storage is very small, so we can rearrange the equation. Loss equal to P delta T subtract Q delta T, but we have to be aware that the delta T is not the same, because for this delta T is, if I highlight this, for Q is 10 now, but for rainfall is, okay, so this is the time scale is different for the rainfall and the runoff. Okay, for the rainfall is 10.5, we convert to meter divided by 100 and time the to convert to cubic meter, time the area. 10.5, 10 power 6. Subtract from 2 cubic meter per second. We have to multiply by 10 hours, 60 minutes, 60 seconds. This means the unit is second per minute. Okay, so we got like convert to cubic meter. For the rainfall, it's about 157,000. Subtract 22,000. Unit is now is cubic meter. So we got the solution for 85,000. okay, for the loss. And C, first problem. So this is the runoff 22,000 divided by the rainfall volume. Move up. Okay, that is the second question. Because the runoff coefficient is equal to 0.46.